All right, so this is, oh, I said concept 15, but this is really section 8.2. This is the last thing that we're going to cover for this term. Okay, so this is 8.2 in the text. We've been working only in chapter 3. A couple years ago, AP threw this in, that this is now fair game for the AP test. And so that's why it doesn't follow along with our chapters in our textbook, but that's fine. It's still covered in. So it's called L'Hopital's rule. So L'Hopital was just a mathematician a long time ago that created this rule that now lets us evaluate limits using derivatives. Okay, but the actual rule is not difficult, and the types of problems we're going to do aren't that difficult either, but it does fit into what we've been doing. Okay, so if it says, if we have two functions, we have f of x and we have g of x, and they are both 0 at x equaling a. If that were true, if our limit as x approaches a means that this is going to approach 0 and this is going to approach 0. Okay, because remember our limit rules, we can take the limit of the top and the limit of the bottom separately. And so what this is saying is my limit is as x approaches a approaches 0. Okay, do not ever write this as 0 over 0. Okay, because what is 0 over 0? Well, what's x over x? 1. So really, 0, anything over itself, you can think of as 1. Okay, and so if you said that, if you said my limit is x approaches a of f of x and g of x, they both approach 0, my limit's 1. That's false. Even if you make this notation and write it down on the AP test in May, they will take points off if you write this. Okay, so we do not want to ever write it like that. I want you to be in the habit of writing that the top's going to go to 0 and the bottom's going to go to 0, and you could just have it with these arrows. Do never ever write it as a fraction 0 over 0. Okay, because I was at an AP training and there was an AP grader that was in there with us, and he was talking about this specific L'Hopital's rule, and he said, he goes, we are instructed if a student writes it as a fraction 0 over 0, that we are taking points away. Okay, because that's kind of a step in the process. That's not getting us to the final answer. But by doing that, you're saying, okay, your limit is 1, when in fact it is not 1. So write it this way. Put your arrows and say the top's going to go to 0, the bottom's going to go to 0, and then you could continue on with your workings. Okay, so again, what does 0 over 0 tell us? Okay, and again, it's approaching. This 0 over 0 really tells us nothing. So don't ever write it as 0 over 0. Okay, because that is equal to 1, and we do not want to say that our limit is equal to 1. What this is, it's called an indeterminate form. Okay, it's not telling us anything. It's not determining anything. It's indeterminate. Okay, so we could end up with this approaching 0 in the numerator, approaching 0 in the denominator as indeterminate form. But we could also end up with it approaching infinity in the numerator and denominator, and approaching negative infinity in the numerator and the denominator. When this happens, it's called an indeterminate form. It's not telling us anything. Okay? So again, we're talking about the limits. What are the limits approaching? And so we're going to focus on the limit as the numerator approaches 0, the denominator approaches 0. But keep in mind, this also holds true if our numerator is infinity, denominator infinity, negative, negative. It all holds true. Okay? Again, the limit is approaching, but never write this in your work as a fraction. All right, so now we can bring into Mr. L'Hopital, who said, okay, if we get this indeterminate form, we can actually do something with that. So what he determined, if you have a function f of a and g of a that equals 0, okay, so our limits, if we did our substitution, we put our limits in, and we end up with 0 in the numerator, 0 in the denominator, but then we're adding this piece in. That, okay, our limit approaches 0 for f of a, our limit approaches 0 for g of a, but we also know that the derivatives at a exist. Okay, this is the extra piece that he put on there. If that's the case, we can rewrite our limits from an indeterminate form to say now the limit as x approaches a will be the derivative at x all over the derivative of g at x. Okay, so we're just going to change it. We're going to find the derivative of the numerator and the derivative of the denominator and then evaluate. All right, so this is L'Hopital's rule. L'Hopital's rule says if you can find the derivative of the top and bottom, find the derivative and then evaluate your limits, and we can evaluate the limit using substitution. Ian. Correct. So now when we do the derivative, it will not end up being 0 over 0, and it will actually tell us what the limit is. Okay, so if we're in this, if we get this indeterminate form of approaching 0 in the numerator, approaching 0 in the denominator, or the infinities, then we apply L'Hopital's rule. We'll take the derivative of the top, the derivative of the bottom, and then evaluate the limit. Okay, let's do one. You'll see. Okay, so let's find the limit using L'Hopital's rule of this function. So the limit as x approaches 0, square root of 1 plus x minus 1, all over x. We would say that we are approaching, I'll write it like this, approaching 0, approaching 0. So if I put 0 in here using substitution, square root of 1 plus 0 minus 1 means this is approaching 0. This is also approaching 0. So we have that indeterminate form. So that's our first key. Okay, because we have this indeterminate form, we can use L'Hopital's rule and find the derivative of each. All right, and I'm going to label the top as our function f of x and the bottom our function g of x. So f prime of x, well, that's this first, right? F of x. So f of x, I'm going to write it without a radical. So 1 plus x raised to the 1/2 power minus 1. So what is our derivative of f of x? Or how would we find that? Chain rule. So I'd bring 1/2 out front, 1 plus x raised to the negative 1/2. Derivative of the inside is just 1, so we're multiplying by 1, we don't have to write that. And then subtracting the derivative of 1 is 0. So really this becomes 1 over 2 times the square root of 1 plus x. So I have 1 over 2 times the square root of 1 plus x is my derivative, g prime of x. All right, g prime of x, well, g of x was just x, so g prime of x is just 1. So what we're trying to do here, we're trying to find the limit as x approaches 0 of 1 over 2 square root 1 plus x all over 1. Well, we wouldn't necessarily have to write it since it's over 1. This is the same thing as 1 over 2 square root 1 plus x. So now, if I were to put 0 in, I end up with 1 over 2 times the square root of 1 plus 0, which is just square root of 1, which is 1. So 2 times 1 is still 2. So my limit on this function is a positive 1/2. So that's what L'Hopital's rule allows us to do. If we cannot find the limit initially, because we end up with an indeterminate form, well, then we can take the derivative of the top, derivative of the bottom, and then evaluate to come up with the limit. Do that.
So like 1/2 would be the limit of the top one and the bottom one, or them two?
It's the top one. Yeah, I mean, it's the top and the bottom. Yes.
Okay.
But this is telling us the limit from the initial problem as x approaches 0, square root of 1 plus x minus 1 over x. Yes, the limit of that is 1/2. As we get closer to 0, they're going to converge on 1/2. Okay, let's do one more, and this is the last one. So again, we want to use L'Hopital's rule to find the limit of this as x approaches 0, 1 plus x minus 1 minus x over 2, all divided by x squared. Okay, if I were to use substitution right now, I would have square root of 1 plus 0, which is 1, minus 1 gets me 0, 0 minus 0 again, so this is approaching 0 all in the numerator. X squared, this is approaching 0 as well, so we have that indeterminate form. So we know now we can use L'Hopital's rule to figure this out. So if I said f of x is 1 plus x raised to the 1/2 power minus 1, and I'm going to write this as 1/2 x instead of x over 2. Same thing. But I think it's easier to recognize, okay, if I want to take the derivative of 1/2 x, that looks easier to me than x over 2. So f prime of x, again, is going to be 1/2 times 1 plus x raised to the negative 1/2 times the derivative inside would be 1, but we went times it by 1, minus the derivative of 1, which is 0, minus the derivative of 1/2 x, which now we will include that, so that would be a negative 1/2. So my derivative is 1 over 4, because I have two 2's in the denominator, square root 1 plus x. G of x was x squared, so g prime of x is going to be 2x. So I have 1 over 4 times square root 1 plus x, all divided by 2x. Let's leave them separate for now. Mason. Because we have, oh, you're right. So that would be, I did mess that up. So this would be, so this would be 1 over 2 times 1 plus x minus 1/2. And so if we did a common denominator in here, and so if we were subtracting, we do our common denominator of 1 plus x, square root 1 plus x. I'm going to end up with 1 minus square root 1 plus x all over 4. No, 2. There we go. 2 root 1 plus x. There we go. I think I did this wrong. Let's actually, that's what it should be, but let's leave it in the other one. We're going to figure something out here in a second anyway. This might be this. Let's leave it as 2 minus 1/2. You'll see in a minute why I'm leaving it like this. Okay, so we're trying to find the limit as x approaches 0 of 1 over 2 square root 1 plus x minus 1/2, all divided by 2x. Okay, so again, I'm trying to put my 0 in there. So if I put 0 in there, I get 1 over 2 times square root of 1, which is just 1/2. 1/2 minus 1/2, this is going to 0. 2 times x, this is going to 0. So we have to now take a second derivative. So I need to figure out now what f double prime of x is and g double prime of x. We have to do it again. Okay. Reason I left it as minus 1/2, because now when we do the derivative of it, that second piece, minus 1/2, the derivative of that becomes 0, so I don't have to worry about that. Okay, but I still have this, so 1/2, and then I'm going to write this as 1 plus x to the negative 1/2 power. So this fraction here, wrote it just like that. So 1/2 times 1 plus x raised to the negative 1/2 power. Now when I do this derivative, the 1/2 that's already there is a constant multiple. I'm going to bring the negative 1/2 down. 1 plus x now raised to a negative 3/2. So my second derivative is a negative 1/4. And then I have in my parentheses 1 plus x to the negative 3/2. Oh, positive 3/2, not negative. Now g of x was x squared, g prime of x was 2x, so g double prime is just 2. So I'm trying to find now my limit as x approaches 0 of these, and so negative 1 over 4 times 1 plus x raised to the 3/2 power, all divided by 2. One plus 0 raised to the 3/2 power, it's 1 raised to the 3/2 power, so it's still 1. So I have a negative 1/4 divided by 2. What's negative 1/4 divided by 2? Negative 1/8. Now I have my final one. So sometimes you might have to use L'Hopital's rule more than once, because if you do it once and you still end up with an indeterminate form, you just got to do it again. Okay? These won't get crazy. You won't end up doing it like 3, 4, 5 times or anything like that. But be aware that if it happens once and you still end up with an indeterminate form, just do it again. Okay? Might be a slim chance that you might have to do it a third time, but then it's just getting redundant. And just for, oh, my thing didn't show up. Had a nice graph there and everything. Okay? All right, so 8.2, L'Hopital's rule in Math Excel, 7 problems, but I want it due tomorrow night by midnight. Okay? So that way you can truly relax Friday, Saturday, Sunday. You're not waiting till Sunday night at 10 o'clock to do this assignment. You already have it done, and you can truly relax. So if you work on these 7 problems for the rest of this hour, you probably can get at least 5 or maybe even 6 of them done. Like these go pretty fast. Okay? So work on these. Monday we will start reviewing for the test that will be on Thursday. So Monday we'll start a review. Test format to be determined. If it's going to be a lockdown browser on Schoology, If it's going to be a PDF where I have you send me images back, I still need to determine how I'm going to do that. But you will be on Zoom for it. And Monday we will be on Zoom together starting at 10:46. So make sure you're ready to go at 10:46 for Zoom.